Attachment theory was built to explain something specific: the bond between a human infant and their caregiver. But almost from the start, people studying it were asking a related question: is this a uniquely human thing, or is it something deeper, something that shows up across the animal kingdom? The answer turns out to be more interesting than a simple yes or no. Some of the most important evidence for attachment theory actually comes from animal research, not human research. And when you look across different species, you find this bond shows up in some surprising places and is conspicuously absent in others. Hello and welcome to Attachment Maps. My name is Carl and I'm here to tell you things that no one else is talking about. So let's go through it: birds, primates, and other animals, and then land on the question a lot of you are actually here for. What's going on with you and your dog, or you and your cat? Let's start with birds, because this is actually where the foundational science came from, even before Bowlby formalized attachment theory for humans. In the mid 20th century, a zoologist named Konrad Lorenz studied geese and ducks and described a phenomenon called imprinting. Within hours of hatching, a gosling will fixate on the first moving object it encounters, normally its mother, and follow it everywhere. Lorenz famously got goslings to imprint on him instead, and they'd follow him around like he was their parent. This is a different mechanism than the attachment Bowlby described in humans. Imprinting happens fast, it happens in a narrow window after birth, and it's largely fixed once it occurs. Human attachment develops more gradually, over months through repeated interaction. But the underlying logic is the same. A newly hatched or newly born creature is vulnerable, and staying close to a caregiving figure dramatically improves its odds of survival. Evolution built a mechanism to make that happen automatically. So in birds, you get a very stripped down, almost mechanical version of what Bowlby later described in much more psychologically complex terms in humans. Now to mammals, and specifically primates, because this is where the science gets uncomfortable but genuinely important. In the late 1950s, a psychologist named Harry Harlow ran a series of experiments on infant rhesus monkeys that, by today's ethical standards, would never have been approved. He separated infant monkeys from their mothers and gave them a choice between two artificial surrogate mothers, one made of bare wire that dispensed milk, and one made of soft cloth that dispensed no milk at all. The monkeys overwhelmingly preferred the cloth mother. They'd go to the wire mother to feed, then rush back to cling to the cloth one. This was a direct challenge to the dominant theory of the time, which held that infants attach to whoever feeds them, that the bond is essentially transactional. Harlow's monkeys showed that contact, comfort, and softness mattered more than food. Bowlby actually cited Harlow's work directly when he was building his own theory because it gave him hard experimental evidence that attachment isn't just about meeting biological needs. It's about something closer to comfort and security in their own right. Beyond Harlow's lab work, primates in the wild show attachment behavior that maps onto Ainsworth's framework almost directly. Infant chimpanzees and other great apes stay close to their mothers, use them as a safe base to explore from, and show clear distress at separation. Researchers have actually run modified versions of the strange situation procedure on infant primates and found patterns that look a lot like secure and insecure attachment in human children. Move beyond primates, and the picture gets more varied because mammals differ hugely in how dependent their young are at birth. Highly social mammals with long periods of infant dependency, elephants, for example, show very clear attachment like bonds. Elephant calves stay close to their mothers for years. The mother and broader herd actively protect the calf, and separation produces visible distress in both. The same is true of many cetaceans, dolphins, and whales, where calves stay near their mothers for extended periods, and the bond is essential to the calf's survival and social development. On the other end of the spectrum, You have mammals with very short or minimal periods of maternal dependency, where you wouldn't expect to see anything like attachment in the Bowlby sense, because the evolutionary pressure that produces it just isn't there. The general pattern across mammals is pretty consistent. The longer and more vulnerable the period of infant dependency, the more likely you are to see attachment behavior that resembles what Bowlby and Ainsworth described. And then there's the rest of the animal kingdom where attachment in this specific sense largely disappears. Most reptiles, most fish, and virtually all invertebrates don't provide extended parental care at all. Many reptile species lay eggs and leave. Many fish release eggs into the water and have no further contact with their offspring. There are some exceptions. Some fish guard their eggs. Some reptiles, like crocodiles, protect their young for a period after hatching. But even in those cases, you don't typically see the kind of selective, individualized bond that defines attachment. It's protective behavior, but it's not the same as recognizing one specific caregiver and forming a lasting psychological bond with them. So, as a rule, attachment in the Bowlby sense tracks pretty closely with extended, individualized parental investment. Where that investment doesn't exist, attachment doesn't really have a reason to evolve. Now, the part you're probably most curious about: what about your relationship with your own pet? Dogs are the clearest case. Domestic dogs have been shaped by roughly 15,000 years of coevolution with humans. And one of the most well documented findings in animal cognition research is that dogs form attachment bonds with their owners that closely resemble the bonds children form with parents. Researchers have run dogs through a version of the Ainsworth strain situation procedure, and dogs show the same basic pattern: using their owner as a safe base, exploring more confidently when the owner is present, showing distress at separation, and settling more easily at reunion than they do with a stranger. There's also a hormonal piece to this. When dogs and their owners interact, eye contact, petting, talking, both the dog and the human show increases in oxytocin, the same hormone involved in the parent-infant bond. That's a real biological echo of attachment, not just a behavioral resemblance. Cats are a more genuinely contested case, and this is worth sitting with rather than smoothing over. Cats were domesticated more recently than dogs and from a more solitary ancestor, and for a long time the assumption was that cats don't attach to their owners in any meaningful sense, that the relationship is more like tolerant cohabitation than bonding. A 2015 study tested this directly using a modified strain situation procedure and found that cats didn't show the secure base pattern in a way that matched the criteria for attachment. The cats explored and played about the same amount whether their owner or a stranger was in the room, which isn't what you'd expect if the owner held a special status as a safety figure. But a later study run by researchers at Oregon State University in 2019 used a different version of the same basic test and found the opposite: that cats do show distinct attachment patterns toward their caregivers, and the distribution looked a lot like what's found in dogs and human infants. A majority of cats showing patterns researchers classified as secure, and a meaningful minority showing patterns consistent with insecure attachment. So, where does that leave things? Right now, the honest answer is that the research is mixed, partly because cats are just harder to test this way than dogs. Cats are more independent, less overtly demonstrative species by nature, so behaviors that could clearly signal attachment in a dog, like obvious distress at separation, may simply not be how a cat expresses the same underlying bond, if it's there at all. The fact that cats don't show it the way dogs do isn't strong evidence that nothing is going on. It may just mean we haven't found the right way to measure it yet. So, does attachment theory apply to animals? In the strict technical sense Bowlby intended, a relationship where one individual uses another as a secure base and a safe haven, distinct from simple proximity or feeding behavior? The evidence says yes, but selectively. It shows up reliably in species with high parental investment, primates, elephants, cetaceans, and notably, dogs in their relationship with humans. It's mechanistic and rigid in birds. It's essentially absent in species that don't provide extended individualized care. And in cats, the science genuinely hasn't settled the question yet. What that tells us, I think, is that attachment isn't some special add on unique to humans. It's a strategy that evolution arrives at repeatedly, wherever the conditions call for it, and your relationship with your dog or cat might be a much more literal continuation of that same biological logic than you'd assumed. Thanks for watching. Don't forget to hit that subscribe and like button, and see you next time.